So it's a great pleasure. Our final presentation goes to the great master, Mr. Francois Louis.
Okay, so here we are again. So for what I remember, everybody was there yesterday? Not everybody. I see new faces, a few new faces. Okay. We were trying to put hair in motion in a pipe. So we blew hair on the edge. Some went in, compressed it, and create a wave. While we get this maximum tension, it's kind of closed by the pressure and the hair goes up. So that's the process with the flute. Also this movement of the hair stream is part of the sound of the flute, for example. This really act like a reed. That's one of the reasons why where you pick up the sound of the flute, there in the embouchure, not on the back. So now, the whole target of this was to get in the saxophone mouthpiece. So before that, let's see how to put such shaped hair column in motion. Isn't it a beautiful saxophone? So, yeah, we could blow hair there, but that won't be that easy. So there is a different system, which is the use of a single reed. So let's forget about the other things, okay? So the single reed bends on the mouthpiece. Main of the thing, what is a mouthpiece? Okay, let's say it's a table with a curve that's named the facing, a flat part on which you put a flat reed shaped like this. Then you have an inside, okay. That's a little weird angle. It's not going to be comfortable to play. Okay. So you have an inner cavity in the mouthpiece. Let's say the chamber, and the tip opening. So you put the mouth around. That's the biggest difference, I would say, is that the flute or other wind instrument, they are outside of yourself. The saxophone, you put it in your mouth. It means that this mouth cavity is also part of the instrument. So your own body is an element of the instrument. So what's going to happen here? You blow hair. So the hair goes in. All the hair goes in. You create the same thing. The hair in the pipe doesn't want to move. So it gets compressed to a maximum tension in the center and create a wave. With exactly the same thing. That while you have this maximum pressure, it's like it's closing and the hair doesn't enter the pipe anymore. The other thing is that also the hair you blow it on the reed. You blow it there, you blow it everywhere. But while you have this balance of pressure, the pressure of the hair you blow closes the reed and the reed comes here. And it's closed. So what happened next? The pressure is released in both directions, in that direction, in that direction. So it comes back there and makes like a counter pressure on the reed. So it changed the inner balance of pressure. At that time the reed gets open, not because of this force, because it's very minimal force, but mostly because of the spring effect of the reed. So the point of balance of this force will be different with a strong or soft reed. So the reed gets open. While the reed gets open, okay, it starts from this point, the movement. Like we saw with the pendulum, this would be our C point and would be O, E, here is the point here. So while the reed gets open, where does it go to? The tip of the reed. Passing by O. okay, goes to O, and from O to a B point. So actually it's true that the reed opens bigger than just being stabilized there. The reed movement is in both directions because it has a proper inertia, and as soon as it is movement, like the pendulum, this has a weight, this has everything to vibrate over this O point limit. So by doing this, I just mentioned that now, okay. We'll see that a little later. Okay. Let's just take it like this and make a bigger mouthpiece. So we step in the mouthpiece. I think everybody wanted to step into that. So, but I told you before, you're aware now that you shouldn't step into that. Beautiful. Looks like the outside of a mouthpiece. Okay. Okay. Let's see, this is in common. So now we are in the mouthpiece. I go quick on different elements, but I explain a few important elements and then I will answer questions because I spent a few years into this little thing, so I could talk for ages. But okay, what is mainly known about the mouthpiece is the tip opening. Just the definition, what is the tip opening? The tip opening is just the distance. If you prolongate the flat part of the table till the hand, here at the tip, the distance between this point and the maximum opening, that's a tip opening. Here in the States is mostly expressed in thousandths of hinge. In Europe we use millimeters. So 1 hinge is 25.4 millimeters. So a thousandth of a hinge is about 2.5 hundredths of millimeter. So all the numbers I use on my mouthpieces are in millimeters because it's way easier, but you have the table, the chart that just translate that in inches. Also, a lot of makers, they use numbers. So those numbers, they don't have the same signification for different makers. That's a little of a problem. That's why I use the dimensions. Okay. So that's the first thing you're going to see, like a 7-ling is 100 thousandths of a hinge tip opening. Other mouthpiece, let's say a 7 of another brand might be a different tip opening. So you have all those comparison charts and things. It's easier to just give the dimension, like the British Burke Larson, they always are expressed in thousandths of inch, sorry. And mine are in hundreds of millimeters. Okay, so this is tip opening. It has a lot of influence, but the main influence actually is the amount of hair that can go through the mouthpiece. If you want to blow a lot of hair, play a big mouthpiece. If you want to blow a little amount of hair, play a smaller mouthpiece. Everybody has his own capacity. Also, it has other influence combined with reeds and things, but we'll see that a little later. Just try to find an opening that's just natural for you. If it's too small for the amount of hair you have, it will break your hair stream and it will have you to force to have the hair enter the mouthpiece, and it's not going to be comfortable. If it's too big, you just get lost and you will breathe for one note. I mean, it's not very interesting if you want to play long phrases. That's another thing too. You have a proper rhythm, and in the music you want to express. You might be someone that play long phrases. You know, there are players, they play short phrases, players that play long phrases. If it's very important for your musical expression to play long phrases, don't play to a big mouthpiece, because you're going to have to breathe more often, even if it's more comfortable. So you have to find a good compromise for your expression. So the second point on the measurement that mostly are given on the mouthpiece is the facing length. So what is the facing length? It's the distance from the tip till what we name the break point, which actually is where the table starts to open in a curve. So it's flat, the reed is sealing and has to seal properly with the table. And from this point, it leaves the flat part. So this distance is the facing length. What is the importance of the facing length? You know, if it's longer, you will have the reed that vibrates on a longer portion. By doing this, the main thing is that vibrating on a longer portion will slow down the vibration, and you have to think, if you slow down, you produce lower frequencies, as we have seen with the frequencies and the length of wave. If it's a longer length of wave, you have a lower frequency. So a long facing will help to develop more of the bottom of the tone. It might be not true if, for example, you play too long facing and you only play it from the tip. So what you're going to do, if you put your lip here and you press, you're going to bring the reed in contact here. So you will just change the position of the break point and reduce the tip opening, and only play the reed like it would be on a short facing. So if you play so, it's no need to use a long facing. Like Jerry says, you take a little of much mouthpiece, depends on the facing length, because he adapts himself and he can play everything. But if your thing is to playing the tip, don't try to play too long facings. So that's the most thing that will have a lot of influence on your control. So we can go a little deeper, because it's a lot of things happening in this thing. So let's just start with the inner cavity, and let's take it as standard as possible. Let's say this is more like a link style, because it's a big open chamber and just air going through. So what we have here, the neck. The neck ring and the cork. Okay, so what we have actually, the chamber of the mouthpiece is the whole thing while you put the mouthpiece on your instrument. So it reduces here. So actually, let's consider this is like this. That's the chamber of the mouthpiece that reduces till here. So this creates, while you blow, some turbulences here. So now we have two things in the mouthpiece. You have the air going through the instrument. A rare thing is that, actually, we can go back to the example of the flute. The hair stream going through the instrument is not interesting for putting the hair column in vibration. It's in the way. As we've seen, it gets closed, and actually the waves in the pipe is just a resonator that gives the frequency of the note you play. but not the whole dynamic. The whole dynamic will come actually for the hair you blow. As we saw with the flute, it's like this hair reed that gives the physical pour of the sound. That's putting pressure on the air, and while it's come back, as soon as the pipe opens and the hair goes back in the pipe, then it's reduce the pressure on the air. So it's this pressure, no pressure, pressure, no pressure at that frequency that brings the sound to your ear. So here it has to go out of the horn. And all this air is perturbating the creation of those waves in the pipe. So we have to try to use it for the purpose we want, to develop the amplitude of the sound, without damaging the creation of the waves into the pipe. So to be able to control all those things, it's important. The way to control that, actually, is really to adjust the balance of the three elements of the hair. You have the speed of the hair, the amount of hair you grow, and the pressure. Of course, if you play the same amount of hair with the same pressure and you reduce the section, you will accelerate it. So to be able to control all those elements really separately is a very important thing. It's what you have to build up as controlling the support of the hair. Is really being able, for example, if you want to have a subtone pianissimo low note that projects, you need a lot of support. You need to put a lot of hair with a little pressure and very low speed, which is very difficult. You can blow for a long time, but you need to support a lot of muscles acting on it. So the control of the diaphragm and thing is very important. So the most stable the hair stream starts in the mouthpiece, the easiest it's going to be to control all those elements. So that's interesting. So we could consider down that perfectly balanced mouthpiece or stabilize the hair stream would be the most interesting. But down it will be a little smaller volume, will have less resonance. It's going to be less interesting sound in terms of complexity and resonance. And also, you can use those turbulences in your sound. Like, for example, Coltrane playing the altissimo with this rough element like a growl without doing a growl. There's all those turbulences that act and give an effect in the sound. So it might be part of your expression. So that's why all those things are kind of complicated to figure out what would be the best. The only way is to try as many mouthpieces as you can. But having a perception on the different elements and what element affects what and what is comfortable for you and what is not. So we try to open doors to have you understand all those elements, so you'll be able to have a better understanding of what is going to be a good mouthpiece for you. So actually, let's say that's the basic of the mouthpiece. So as we've seen, we blow, the reed stops there. Then gets opened in here, this point B. So it makes a very particular acoustic signature, which is really part of the signature of the saxophone sound. And we didn't see that, but as we have seen, the sound is a movement, so developed in the time.